Okay, lesson 6, functions. So again, I would call this algebra review, I think, if we're talking about functions. Equations, graph, function notation, domain and range, all that stuff that you've been doing for several years. So, there's a definition of function there. Any equation in which every individual x value, remember x is also the domain value. So every individual x value maps to only one y value, and the y value is also known as the range value. So definition of a function. Each and every x maps to one and only one y value. They show a function machine there, which is not something I do a lot with, but just the idea of basically on the left is your input, goes through the function machine, on the right is your output. So just, what's the function doing to the value? So like in this case, if the function is 4x, you put in 2, you're going to get an output of 8 because 2 times 4 is 8. You put in 3, you get 12. You put in y, well, 4 times y is 4y. So just the concept of a function machine. Now, what I want to look at is example 1. Given f of x equals x squared plus 5. There's 3 parts here. Find a, which is f of negative 2, b, which is f of x plus 2, and c, which is f of x plus delta x. So let's try a. F of negative 2. How do I find f of negative 2? Yeah, plug it in for the x's. So if f of x is x squared plus 5, negative 2 squared plus 5. Negative 2 squared is 4, and 4 plus 5 is 9. Okay? Let's try b. Let's get a little more challenging. F of x plus 2. So every place I see an x in the equation, I'm replacing it with x plus 2. So x plus 2, quantity squared, plus 5. What is x plus 2, quantity squared? X squared plus 4x plus 4. And what about when you add that 5 in there? Becomes a 9 instead. So how do you feel if I write this as x squared plus 4x plus 9? Are you guys okay with what we did with the x plus 2 quantity squared now that people are saying it? We foiled it, right? Yes? I know there was some hesitation. X plus 2 times x plus 2. X squared, 2x, 2x, and 4. That rings a bell, I hope. Okay. Not saying you have to write it out and, do all the foiling, but if you need that review, that's where I'm going to throw it up there. Okay, let's try C. F of x plus delta x. And I will tell you, this is our calculus book kind of doing a foreshadowing of upcoming events later on down the road. So just being able to substitute in that x plus delta x is a necessary evil that we will have to deal with. Okay. So every place I see an x, I'm putting in x plus delta x. So it was x squared. Now it's x plus delta x squared plus 5. Okay. Well, FOIL with me. First is going to be x times x, x squared. Plus. Okay, if we just think one piece, what are the outsides? X times delta x, which x times delta x is x delta x. Or delta x, then x delta x. I like that better. What are your insides going to be? It's going to be another x delta x, right? So what's x delta x plus x delta x? 2x delta x. So I'm going to write that as 2x. And traditionally, in this situation, you tend to see them put like the delta x in parentheses. And I guess if nothing else, that way if you write it as delta x, x, you can tell that they're two separate things. Okay. Plus, what's last? Delta x times delta x is delta x squared. And for official sake, I'm going to write it as delta x in parentheses, then the squared outside. Just because you want to make sure it's not just the x that's being squared, it's the delta x being squared. And then don't forget, what else do we still have we need to tack on here? Plus 5. Any more cleanup I can do there? No, there's not. And keep in mind, x and delta x, they're not the same thing. They're not like terms. Not that you even really understand a whole lot about delta x right now. Where's the one time you have seen delta x in math, possibly? Physics. What about math? What'd you say, Ethan? Yeah. I mentioned it just this morning in pre-cal. It comes up in the definition of slope. Because the definition of slope is change in y over change in x, and delta represents change. Okay? So, yeah. Okay. You guys okay with example 1 then? Okay, let's try example 2. Use a graphing calculator to estimate the value of f of pi, f of square root of 2, and f of cosine 5 square root of 3, where f of x is 1 over the square root of 1 plus x squared. We went from all these nice, easy numbers to this. But we get to use a calculator. And when they say estimate this, they're wanting a decimal at this point. And you can't get a decimal without the calculator. So, everyone have a calculator with them? Okay. Thoughts on how I can do this? What are you guys doing? You're putting that in, and so you're going to have to put that in, 3 different times, right? Okay. And I'm not against that. My question, though, how can a graph help us do this? And what you're doing is not wrong by any means. I'm just trying to include another idea here. How can a graph help us? Let's practice with a graph. Just, you guys know how to plug it. You guys know, find the pi button on your calculator, plug it in. You guys know how to do that. Okay? Take a moment and graph this. So go to your y equals and graph. Put as a fraction 1 over the square root of 1 plus x squared. With a little bit of work, can you remember how to enter that on your calculator? And then go ahead and bring up the graph, which I like to do my Zoom 6. Are you guys able to see mine okay? Minus, okay. I mean, the normal glares, but. Okay, so we have this graph, yes? And how do I find the value of pi when x is pi? You can trace it, but are we going to get a specific answer? Okay, so if you trace, and there's 2 different ways you can do this. The shortcut is, if you trace, once you're on trace, if you just type in pi, it automatically pops that up and puts it as an x value down here. And once it says x equals pi, if I hit enter, it's going to take me straight to pi and give me the coordinates. It's finding the value at pi. And so it's x is pi and y is what? 3.0331447? Did you guys get that? 0.3033. Sorry, I think I said it wrong. Okay. The other option to do this, if you go into your calc menu, second calc, number 1 is value. And that's doing the exact same thing. If you go to number 1 there, which is value, and hit enter, notice it says x equals down there. So it's saying, okay, give me an x value, hit enter, and I'll take you to that point, and then you'll have the y value. So x equals pi, and there we go. So what is the value of f of pi? Okay. Using the Saxon book, I used 0.3033, which is 4 decimal places. AP Calc would only require 3 decimal places. So once you get it graphed, you can either go to trace and then enter the value, or you can go to, trace and second calc and do value on the menu there. Looks like I wrote that right. Okay. Okay, have you tried B then? B was f square root of 2. So you could go back and just plug it into your calculator like normal. That's fine. It works. If you're using the calculator shortcut, all you have to do is hit trace all over again, I think, and you just go square root of 2. And when I start typing, it pops up that x equals button. Hit enter. And when x is square root of 2, y is 0.5774 or 0.577. And then, what about C? If I do trace, keep in mind, it's not just 5 square root of 3, is it? It's the cosine of 5 square root of 3. And you can just type that whole value in, cosine of 5 square root of 3. You don't have to end your parentheses here, but you can. Does your answer match my answer? 0.810875557. So why do some of your answers match mine and some of your answers do not match mine? So what mode do we need to be here since they gave us a trig function? We need to be in radians mode. Because it says cosine, because we're using a trig function, you automatically assume radians mode unless there's something indicating degree mode. Okay, unless it says find it in degrees or, they give you degrees or something, automatically. So, try changing the mode on your calculator and then see if you can get my answer. Which my answer was 0.8109 is what it rounds to be. I don't know if anyone, I could tell Abby had the wrong mode because she had that look on her face of crying. Why don't I have the right answer? Now she's nodding at me, so that must be good stuff.
Yeah, I got it right this.
Okay. So, Yep, get those calculators in radians. Unless you have reason to take them out of radians, I just leave them in radians. Okay. So that right there, my whole point was kind of reviewing, okay, how can we use a graph to help us? Example 3. Use the graphing calculator to find f1, f2, f3, so on and so forth, all the way up to f of 10, where f of x is square root of 1 over square root of 1 plus x squared. You can. I've got another option to show you too. Okay, so one option, can we use the graph here and plug them in that way? You know, like what we just did, yes. Could you go back to the old school and plug it in 10 different times to your calculator? Yes. And I'm not saying those are bad, okay? That's not what I'm saying at all. Okay, because sometimes what you know we can go to quickest is best. However, do you remember doing list last year? It's been a while, right? But if you go into your stat and then edit, we use the list options because that's the option I'm going to show. Now, obviously the function we're using is going to be this 1 over the square root of 1 plus x squared. If you go stat and then just hit enter and go into edit. First of all, to clear a column, if you have junk hanging out in your columns like I do not delete or you will delete the whole column. You want to do clear and enter. If you go up to the heading, clear and enter will clear out the column, but do not delete the column or you will disappear that L1 and L2 for good. Well, until we put them back in there, which I don't remember how to do. So now, in L1, what's going to be my input? What are we trying to find? Well, 1 over square root of 1 plus x squared is going to find me my output. What am I going to put into that? What are they asking me to find? F1, F2, F3. So in column L1, I just put 1 through 10, which are basically my x values. Okay, so in L1, I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, those are what I put into L1. Now, what do we put into L2? Do you remember how to do this? Go up into the L2 heading and type your formula. So it says L2 equals, I'm going to do a fraction bar, 1 over the square root of 1 plus, where are my x values? They're in L1. So what do I want to square? L1 squared. L1 is the second function of 1. Can you guys see that? So in L2, it says L2 equals 1 over the square root of 1 plus, it gives me 10 values, just like that. Or it doesn't. Sorry, I was watching your face, Kaylee, and it didn't for whatever reason. Okay. Yes? I can do that. Okay. So here where it says L2 equals, right? I'm up in that header. And I'm going to enter it just like I would. So like I went ahead and did my fraction bar. I did 1 over the square root of 1 plus, and this is where we would normally type x squared, right? but all my x values are over in L1. So I'm going to type L1, which L1, if you go down and look at your 1 button, the number 1, it is the second function of number 1. That's what Abby needed to hear. So right there on the 1, and I guess I haven't zoomed in too much, but down on 1 you see an L1. So I'm going to do second and my 1 button, and it pops up an L1 there, doesn't it? Now if I hit enter, I'm going to get those numbers again. Why? Oh, you know what? I forgot to square it. Did I square it the first time? Okay, this time I forgot to square it. I know I did this time. I'm like, those are not the same numbers. Okay, so I need to do some troubleshooting is what you guys are saying. Do we have 1 through 10 in the L1 column? Okay, try it again. Now, get up. Okay, you need to get up in the L2 heading. You're right there across from 1, so get up there in the heading and type in the equation. That's why it's only, because it's only doing it because you're just putting in for 1. And so, yep, there you go. Except not x squared. You want to use L1, right? Yeah, you should be good to go.
Okay. I'm putting X.
That's the other part of the problem. I don't know which problem was which time, but that was the. You figured out your issues. Okay, you guys are good back here.
So this is what it should be looking like, right? Where it's just gives you a bunch of numbers.
Yep. Should match the numbers I have going on up there.
Yeah.
Now, in all honesty, was that any quicker?
No.
No, because we had to figure out the skill, right?
Eventually.
Now, if you remember how to use this chart, it can be quicker. And there are times it's good to use this. Honestly, yeah, you guys are like, oh my gosh, I would have been done with this problem such a long time ago if you would have just let me type it in and do it my own way. I get it. I'm just trying to review skills with you, okay? So, okay. I'm going to write down my L2 values here and realize in L2 I put 1 over the square root of 1 plus L1 squared. So 0.7071, 0.4472, 0.3162, 0.2425, 0.1961. And then over across from 6, 0.1644, 0.1414, 0.1240, 0.1104, 0.0995. You guys got all those values? Again, it was 1 over the square root of 1 plus L1 squared. Okay. Move along when you guys are ready. Okay. Function notation. Okay, example 4. What do you remember? Which of the following are not graphs of functions? What? Yep. Vertical line test is exactly what we need to think of. So if we're talking vertical line test here, what? Which ones are not functions? Second one is definitely not, because if I draw a random vertical line, I just touch that graph 3 different places. So that one's definitely not one. Thoughts on the others? Okay? Because we have these stair steps going on, those stair steps cause the problem, right? So because you have a vertical line there, that is definitely not a function. And why are these not functions? Because they are
Yeah, the same Y, or they have the same X value.
Yep. Okay. Same X value paired with multiple different Y values there. So they are failing the vertical line test. Okay. What about the first one, this diagonal line?
That is a function.
That's definitely a function. What about this third one?
So now, am I correct in saying that since only one of the circles is filled in, on that graph only exists at that point because the first circle on the top one isn't filled in, so that means that it actually doesn't exist right there.
Right.
So wouldn't they be a function?
Yep. Yeah. So that one is there to trick you. If both of those dots are lined up on the same vertical line and they're both closed, filled in circles, then that fails the vertical line test. Okay? But because one is an open circle and one is a closed circle, it passes the vertical line test because there's no other place we have two on the same vertical line. That was the only debatable. But because it's an open and a closed, we're good. Okay, so that sounds familiar, right? Which of the following sets of points could lie on the graph of a function? So which of the following could lie on the graph of a function? Oh, you know what? There's a typo here, isn't there? Yeah, A and B are the same, aren't they? And that's why I was just like, oh, I remember this one. There's a typo. Because we're asking the same question twice. So make this 3-4 a 1-4 on example B. And then we're not doing the same problem twice. Okay. So what about A? Could A lie on the graph of a function? Yes. And why yes? Okay, yeah. 1, 2, 3, and 4 are my X values, right? None of my X's repeat. That works. Okay? What about B?
B could not be because 1 equals 2 anymore.
Yeah. Because I changed that typo there, yes? 1 pairs with 2. 1 pairs with 4. That cannot be a function. Okay? What about C?
So, am I right in saying that C couldn't be because it goes 4, 3, then goes to a different one, but then goes back to 4, 3, which means it wouldn't pass the vertical line test?
These are just sets of points, though. They don't connect.
Okay. So it's good. Yeah, that can be.
Okay, yeah. Yeah, if you're thinking about the fact trying to zigzag the points around, though, these don't connect. These are just individual points. And the catch is, some people are going to be like, oh, there's 2 4s. It's not a function. However, those 2 4s both go with 3s, and since it's the same point, we're okay there. C is a function. And what about D? Yeah, that's going to be a function as well because each of my X values are unique, right? So if you want a side note to yourself, the domain, which are your X values, cannot repeat. Okay? Or if you want to put on there, the domain cannot repeat or cannot pair up with a different range or, multiple different range values. However you want to put it. Okay. Example 6. Determine Determine whether the following statement is true or false and justify your answer. The mapping f as x is mapped to x to the fourth plus x squared is not a function because it maps both 1 and negative 1 to 2.
So is it saying that 1 negative 1 are x values or 1 negative 1 are y values?
If it maps 1 and negative 1 to 2, 1 and negative 1 are x values.
Okay, so that's a false statement because it could be a function because there are 2 different x values going to y values.
When it's talking about it maps 1 and negative 1 to 2, what their claim is that when you put in 1, f of 1 is going to work out to be 2, and f of negative 1 is also going to work out to be 2. That's what they're claiming there. Does that make sense? Which, if you think about it in ordered pairs, those ordered pairs are 1, 2, and negative 1, 2. Do those represent a function? Yeah. Can my y values repeat? Yeah, as long as, they can repeat. It's okay to have 1, 2, and negative 1, 2. Now, if they're the same x values, it wouldn't be okay. So, they said this mapping is not a function. So, we're going to say false. Yeah, half the battle is understanding what they're saying here, isn't it? I'm going to say 2 different x values can be mapped to the same y value. So 2 different x values can be mapped to the same y value. Okay. Example 7. Determine whether the following statement is true or false and explain your answer. The equation y equals 1/2 x squared plus 2 is not the equation of a function because there is a vertical line that intersects the graph of this equation at more than one point. Well, here's mine. I want a visual. If they're going to talk about vertical line intersecting this graph, I need to be able to come up with a visual. Okay, this is where you use your brains to come up with what this graph looks like. It's 1/2 x squared plus 2. What shape are we going to be talking about? You see an x squared, so it's a parabola, right? Okay, what's the 1/2 going to do to that parabola? How about, it's going to make it wider. It's going to stretch it wider. Yeah, so I guess shrink from a vertical, make it wider. Okay, but still, it changes the shrink and stretch, right? What's the plus 2 do? Moves it up 2. So the idea here is that this graph, it goes up 2, looks something like that, right? Okay, this is where, all those 12 graphs we learned last year in lesson 1.3 of pre-cal. Yeah, you have to know this, okay? Yes, calculus expects you to know, they expect you to be able to graph a general version of that by hand because they want you should know that stuff by now, right? So, what were we doing? The following statement, is it true or false? This equation is not the equation of a function. What are we going to say? Yeah, so this is a false statement. What's your explanation? Yeah, since it says because there is a vertical line that intersects the graph at more than one point, it was, just internally intersected once, or I'm going to simplify it and say it passes the vertical line test, right? So the graph passes the vertical line test. I don't know, however you want to explain it, right? Okay, example 8 when you're ready. Trying to keep us moving here, make sure we get through it. Find the domain and range of the function. F of x equals square root of x plus 5. Remembering f of x is the same as saying y, right? Let's see, which way I'm trying to decide how I want you guys to think about this. Huh? Okay. And, well, here's what I see. Okay, so for domain, we need to talk about what x values can we or can't we use. What do we know about a square root? It can't be negative. So, because there's a square root, when we talk about the domain, that value under the square root, so x plus 5 can't be negative, so it has to be greater than or equal to 0. Does that make sense to you? Under a square root has to be positive, because we can't take the square root of a negative, we're just talking real numbers. So x plus 5 has to be greater than or equal to 0. Can you solve this? X is greater than or equal to negative 5. Now, some fancy notation, because you're going to see some fancy notation in this calculus book. And it's just good notation to be familiar with. May or may not see it on calculus exam. I'm not 100%, I don't really remember right offhand. But, so rather than them just saying the domain is x greater than or equal to negative 5, they're going to use braces and say x is a member of the reals such that x is greater than or equal to negative 5. That made perfect sense to you, right? Okay, this is at least going to give me a sure, whatever you say. Okay, so it's, I don't know if you want to call it a little E, or it's almost like a C with a line in it. That thing I drew there, it's almost, it says is a member of, or is a member of this set. So it's probably more of like a C with a line in it. But when you put that line in it, it makes it look more like a funky E. Okay? And so this is just fancy notation. X is a member of the reals such that x is greater than or equal to negative 5. So that's saying that any number in the reals that's bigger than or equal to negative 5 works. Okay, now, that was domain. I started to write. This is supposed to be range. I started to write the funky R, and I didn't mean to. Range. Range are the y values, yes? What do you know about the results of a square root function? They're always positive, yes? So what we can think about here is the fact that the square root of x plus 5 is always going to be positive, right? But what is square root of x plus 5 the same as? Square root of x plus 5 is the equation here, which means it is y. So basically we can say that y is greater than or equal to 0. Okay, because basically the function is a square root. A square root always has to be positive. So y always has to be positive. Now, we can write this in the fancy notation. It's called set notation. So I'm going to use a brace. This time it's range, so instead of saying x, I'm going to say Y is a member of the reals. That vertical bar indicates such that Y is greater than or equal to 0 in my braces. So yeah, that line in the middle is just a vertical bar. And it is read as such that.
So, on our homework,
The answer key will have them in that form. It's something to be familiar with. As you go into higher level math, I don't want you to run across this somewhere and be like, what is that? You know, if you're familiar with it, it's not going to throw you off as much, okay? I would say try and practice writing it a little bit in the homework just to, you know, get familiar with it. Example 9 says use the graphing calculator to verify the domain, which means if I'm going to use the graphing calculator, I'm going to graph this, yes? So square root of x plus 5. Do you remember what a square root graph looks like?
yeah.
Okay, I mean, I've already graphed mine, got mine up there, but square root graph, it's like half of a parabola turned sideways. Normally it starts at 0, 0. But where's this one starting at? -5, because it takes, that x plus 5 takes the graph and moves it left 5. Okay, now, to verify this, I mean, you can use the trace feature, and you can arrow left if you want. And as we arrow left, notice, okay, I still have a y value there. And as I go over left, at -5, 0, I still have a y value. If I go farther, notice my y value ceases to exist. When your y value ceases to exist, that tells you the graph does not exist at that x value. And so that's kind of our, you know, how we can verify it there. So I'm just going to write a note about how I did that. And I'm going to say I used the graph and trace feature. Once left of x equals -5, the y values cease to exist. Okay, so, you know, write something to talk about how the graph helps us there. Okay. Example 10. Find the domain and range. Now, we are going to look at the graph here in a moment, but before I look at the graph, there's something to be said for being able to look at the equation and look at certain features there. What kind of features do we have on this equation that are going to restrict my domain values? Okay. What do you remember about your denominator? Cannot equal to 0. Now, so that means if I set my denominator equal to 0 and I solve it, we're going to find out that x cannot equal 2. So yes, good vocabulary, that is a vertical asymptote. So x cannot equal 2. And I knew that just by looking at my denominator, setting it equal to 0. What else do we have in this that restricts our domain values? Yeah, there's a square root of x. So because we have the square root of x, that has to be greater than or equal to 0, which is basically going to say x has to be greater than or equal to 0 here. Now, nice news is you can take those two pieces, you know that fancy set notation? I can write them like that. I can say, braces, x is a member of the reals such that. The general thing is that x is greater than or equal to 0, except that, so I'm going to say, comma, x cannot equal 2. Okay, so we did that last year, right? When we talked about domain, I always said look for denominators, look for radicals. Those are the two big things that are going to restrict your x values. Now, range.
Whatever's graph.
What?
It can be whatever's in the graph, right? So it wouldn't be
Yeah, it's hard to know. I mean, it seems like anything. I mean, because even then, we're going to get negatives come out of here because x minus 2 can result in a negative. So my recommendation is to check the graph out. And so if I graph this real quick, square root of x over x minus 2. And if I graph this, we have this lovely thing happening. Now, remember, we're talking, well, first of all, does our domain make sense now? We said x greater than or equal to 0, which notice there's nothing over here, and we accept that x could not equal 2. So the domain makes sense, right? You can kind of check your domain. What about range? Remember, range are my y values. How low and high does this graph go? Well, it goes down to negative infinity, doesn't it? It's going up to positive infinity. So it seems like now, where's the question we kind of need to double check? Well, it's not so much that, but does it exist at 0 or not? And here's where I would do is I would hit trace, and notice what it does when I put in trace. It gives me 0, 0. Does it exist at 0? It does. And over here to the right, it appears to be an asymptote, which means it's getting closer and closer to 0. So those values are going to exist. So this is an all reals type thing. Okay? It does exist everywhere. And I'm going to use, you know that fancy R? I'm going to say all reals. Okay? Now, my explanation, or a note to myself, is I looked at the graph, and I'm going to say all appeared to work. I'm also going to note that I specifically checked 0, because that was the one that, whoops, there was a break there. And so it's hard to know, did it actually work there? Okay. So that is lesson 6. Obviously, you can look at problem set 6 tonight.